Okay, and we are live. Welcome to Lectromec's Summer 2020 webinar on integrating EWIS into fleet sustainment and MECSIP, partnering with MECSIP managers to integrate industry-leading EWIS analysis and certification into life cycle sustainment. I'm Mike Traskos. I'm the president of Lectromec, and also here as part of this webinar presenting with me is retired Brigadier General David Urich. This presentation is something we were hoping to give at the MECSIP managers meeting that was supposed to happen in June 2020. Unfortunately, due to the cancellations associated with COVID-19, we were unable to, the meeting was canceled, but we still want to make sure this meeting was available or this webinar was open and we could present this to the MECSIP managers. And obviously we sent out this invite to those that receive the Lectromec newsletter, and hopefully this is something that you'll find interesting and informative. While the electrical wiring interconnect system, EWIS, evaluations and sustainment requirements have been part of the mechanical equipment and subsystems integrity program since 2013, it is only just recently that EWIS elements are part of the performance measurements. This webinar provides an excellent opportunity to improve your understanding of EWIS, EWIS requirements, and highlights a path for a better and more cost-effective EWIS evaluation. I see from the list of attendees that we have a lot of representation from both industry and from the armed services. So if there are some elements of this presentation that are not familiar to you, we ask that you go ahead and ask questions. But we'll have an open discussion at the end of this meeting, and you also can add them into the sidebar in the question area. So this is directed towards the armed services, to the U.S. Air Force and the MECSIP managers. So some of the topics seem a little bit different than the commercial side. Every group has their unique set of voices. Your mics will be on mute until the end in Q&A, and then we will allow for open questions through the microphones or through the side panel. Our agenda today includes a discussion of the EWIS, the current state of the EWIS, the components of an EWIS program, the MECSIP scorecard, solutions for MECSIP managers, and then we're going to talk a little bit about what the Lectromec story is, where we come from, and kind of the reason we believe we can help in this area. And then lastly, we'll have a discussion, final thoughts, and an opportunity for moving forward. With that, I'll pass it over to David.
Okay, thank you, Mike. Hello, gang. David Urich here, 30-year Air Force veteran, retired about 4 years ago. So let's get into EWIS. The slide's titled The Current State of EWIS, but it could be titled Implications for Not Doing EWIS. As you all know, EWIS has been around for a while, and it doesn't always get a whole lot of attention amongst all of the other life cycle sustainment activities. But there are implications to having a poor EWIS program. Not always easy to quantify. About 10 years ago, the folks at Pax River took a stab at it and did a very involved and massive maintenance data evaluation. Commercial industry has been looking at it for about a decade as well, trying to understand electronic failures that cause smoke and fire. So we've got some data from the early days, but really over the last 10 years, we've gotten a little bit more sophisticated. And as you can see from these bullets, some of the more recent data gathering efforts have shown that, like, the Naval Systems Center Command estimates that about $75 million is spent annually on wiring-related troubleshooting and maintenance. And if you extrapolate the numbers of aircraft that study was based on to the Air Force, it could be as much as $120 million. That's avoidable. On the commercial side, they estimate that 3 to 10% of all of their maintenance hours are spent on wiring. That's unscheduled maintenance on wiring, and you could probably make a similar judgment about the Air Force's aircraft too. And whether it's commercial or military, that's way too many hours on unscheduled maintenance due to wiring issues. In 2019, April of 2019, just a little over a year ago, Mr. Watson, the Deputy Assistant Secretary of Defense for Material Readiness, put out a memo to all of DoD addressing the electronics intermittence across the DoD sustainment enterprise. And in this memo, he says that electronics maintenance is a leading driver of weapon system non-availability, accounting for $10 billion in FY18 sustainment costs. So that's a lot of money in non-availability. And he says it's not uncommon for up to 50% of electronic components entering maintenance to be no-fault founds, and that intermittent electronic failures are a leading contributor to the DoD's no-fault found problem. So guidance from DoD on getting our EWIS program up to standards. And then lastly, before the slowdown in the commercial flying industry, the top 5 commercial airlines were reporting an EWIS-related emergency aborted takeoff and diversion once every 6 days. So that's a lot of, I'll say, lost revenue and additional cost. Yet, despite all of this, and the clear advantage of having a quality EWIS program, very few, if any, of our fleets are completely compliant with the MIL standard or the handbook. And so we're going to get into the components of a quality EWIS program in the next few slides. But before we do, Mike, could you tell us what we're looking at there on the right?
Certainly. So the photo that you see here on the right is actually a photo we took while out in the boneyard investigating, doing a visual examination of several F-18s. This is a polyimide or capped-on wire, and for those who are not familiar with it, it might look like that the conductor of the wire is actually exposed. This is unfortunately one of the challenges with particularly capped-on wiring, is that it's a clear insulation. It's amber colored, so it looks like you can see copper. But the interesting part is that wire is actually fully intact. Kind of the reason we have this photo here is it's difficult and basically impossible to visually identify degradation of wiring insulation and other EWIS components. This wire itself might look like it's gone through hell and come back, but from a chemical perspective, from an integrity perspective, it might actually still be good for another 5, 10, 15 years. So kind of what I want to highlight here is it's a visual examination can help to identify the big problems, but in terms of identifying the wiring health, it requires a little more than just the visual examination. David?
All right, thank you, Mike. So many activities associated with the quality EWIS program. If you looked at the handbook and you're familiar with the MIL standard 1798, especially the EWIS section of that, you're familiar with the 7-step process and all of the moving parts associated with that. And what we're going to focus on today are 4 of those foundational building blocks of an EWIS program that track to the 4 reportable requirements that Mr. Rizzuto has added to this year's scorecard. So we'll call these the big 4. Mike will talk about them more in depth, but I'll give you just kind of an overview of those 4. Starting on the top left, do you have a process for capturing an EWIS maintenance data? Everybody's got a lot of maintenance data. Are you able to pull out those maintenance records and activities that are relevant to an EWIS program? Next, moving to the right, and if you're able to do that, are you using that maintenance data to direct and guide your sustainment actions? Are you using this information to be proactive before problems get too big? Moving down to the bottom left, Mike mentioned the wiring on the previous slide. Do you have an inspection program to understand the current EWIS condition? Are you physically, visually looking at wiring to understand the wiring's health? Do you understand your high vibration zones and your extreme environmental zones, those areas of the aircraft that will degrade a wire more quickly than others, chafing, maintenance actions, those type of activities? And finally, do you have an EWIS risk assessment program to understand the current and evolving risk? And as Mike pointed out, moving from an inspection program, which is primarily visual, to an assessment program, which requires a physical examination, is kind of a big step forward, but it's also a much more revealing a step in an EWIS program. And all of this is really to identify risk before vehicles get grounded, before fleets get grounded. And I will say that when we look at an EWIS program, at least from our standard, what we see is an opportunity to, it's kind of the bumper sticker here, to increase aircraft availability and reduce life cycle costs by reducing the number of no-fault founds, the amount of time aircraft spend in depot, and reducing unscheduled maintenance due to wiring issues. But aircraft availability increased, life cycle costs decrease is kind of really the foundation of the results of a good EWIS program. Next slide. But in our experience, there are perceived roadblocks to successfully implementing those 4 foundational building blocks of a good EWIS program. Just looking at the first one, do you have a process to capture the EWIS maintenance data? As I mentioned, there's a lot of maintenance data out there, but there's really limited expertise and experience to separate the EWIS maintenance data from the overall maintenance data. Although it's outlined how to do that in the handbook, our experience working with the fleets has been, it's just something that they're finding difficult to do. And of course, if you don't have good EWIS maintenance data, it's hard to use information to direct your maintenance and sustainment actions. And if you did have good EWIS maintenance data, you still may lack the resources and the feedback loops to determine the actions and the effectiveness of those actions. Moving down to the third one, the inspection program. Having spent 30 years in the Air Force, inspection programs are usually higher headquarter mandates that come unresourced and unfunded. And sometimes it's just difficult to get 2 more pounds of feather in that 10-pound bag. And sometimes it's easy to publish a MIL standard. Sometimes it's difficult to be in compliance with it based on the resources, the expertise, the training that's available to each of you. And then lastly is the EWIS risk assessment. This can just appear as such a daunting task. It's even difficult to know how to begin. When you consider the tens to 100s of miles of wire in an aircraft, the need to look at the aircraft's age, its block, how many sorties it flew, its maintenance records. Was it a plane that spent a lot of time in the humid Southeast Asia, or the dry Southeast Asia, the desert environment, or was it on an aircraft carrier in a humid, moist environment? All of those things get factored into a risk assessment, and they can, like I said, can appear so daunting. It's difficult to know where to start. And so, what we want to convince you of is that there is a process to accomplish all of these. There's tried and true methods, and there's experience out in industry to help you through this, and that it's not as daunting as it looks, and it's not as difficult or insurmountable as it may seem. So Mike mentioned earlier, and I mentioned as well, that Mr. Mazzuto has added 4 elements to your scorecard reporting in 2020. So just a couple words on how we got here. Really, EWIS or wiring maintenance wasn't a concern for many about 10 years ago. In 2010, there was a large fleet of 30-year-old aircraft that was going through a service life extension program. And the fleet engineer started working with AFRL and debating the need to have a degradation study of the wiring system or not. And after a lot of back and forth, it went up to a 2-star who made the decision that we just weren't going to do that. And so the AFRL guys went back and they realized that they sort of lost the argument because there wasn't enough analytics or quantifiable information about an aircraft's wiring system health to make the case for a degradation study. So AFRL partnered with other military organizations and commercial organizations and built that first EWIS handbook 525. From that, many of those thoughts were incorporated in August of 2013 into the MIL Standard 1798. And as we said just recently, Matt added 4 of those elements to scorecard reporting. And the whole point of all of this is, like, as Peter Drucker said, if you can't measure it, you can't improve it. So through the actions of including these in the MIL Standard, and now Mr. Brizzuto asking certain things to be measured, we're at a point where we can start to improve the EWIS environment. And with that, I'll turn it back over to Mike to get into some scorecard specifics.
Thank you, David. So these are the 4 elements that were specifically on the scorecard. First, we start with the question was, is there a documented process for collection of EWIS failure and maintenance data? Followed by, is the EWIS data analyzed to determine the hotspots, systems that are commonly impacted, and the scale of EWIS repairs? Physical aircraft related inspections, if they're conducted, and what are the findings, and if they are documented. And then lastly, is an overall EWIS risk assessment and has been completed. Now, for those that are part of the MECSIP community on this webinar, how did your scorecard look? Was there a lot of red, yellow, or green when these sections were answered? Obviously, we hope that for your sake there was very little red. For our sake, they hope that you're taking care of it or would need a little bit of help. But these elements are kind of core to an overall assessment, and we're going to focus on these one by one through the next several slides. First, talking about the data review and analysis. Those that have reviewed maintenance data know the difficulties of extracting useful information. Certainly, if you're a part of any organization that's been collecting maintenance data, you're going to have thousands, potentially millions of rows of data that hide useful information. Anyone that's ever tried to look for EWIS information in those large databases of maintenance actions know the difficulty behind that. Oftentimes, the maintenance actions for wiring are placed under other work unit codes. So if there's a repair done on the engine that is only related to the wiring, oftentimes in maintenance reports and general evaluations of the maintenance data, you find that the engine is doing terrible and the wiring system is doing great. Really, the only way to identify and really quantify the scale of the EWIS maintenance is for advanced filtering algorithms of that maintenance data. Those that have gone to Joint Service Wire Action Groups, JSWAG, or MECSIP meetings have heard presentations and reports of the thousands of man hours that have been used to try to manually go through maintenance data, and the amount of effort that's gone into that. There are advanced data filtering algorithms to help reduce that effort, and those in the MIL Handbook 525, there is some guidance in terms of keywords that can be used to help identify it. But searching maintenance data is more than just looking for keywords. It's about understanding the intent of what's being written. If you are only looking for a keyword of wire in a report, then you're also going to pick up lock wires. You're going to pick up flight control cables, and not the physical ones, not the electrical type. Those are things that are not part of the EWIS. If there is a light bulb out in the exit sign, or the fire indicator, that's a component failure, not an EWIS failure. And those types of things that need to be picked at, advanced filtering algorithms must be able to do in order to reduce the amount of manual intervention. Also, the algorithms that are employed have to be able to differentiate and try to tie together no fault found incidents. So for example, you have a LRU that has been replaced 2 or 3 times, and then finally on the 4th time, it's been identified that there was an EWIS issue. From a maintenance standpoint, those first 3 events should not be tied to the system, but should be tied to the EWIS event. And a sort of advanced analysis of the maintenance data should be able to tie those all together as part of a single EWIS failure. Now, these tools and techniques for maintenance filtering have been developed by Lectromec, and we regularly employ them across various projects. As part of our analysis, we regularly go through and manually review the results of it, and we find that we get about 80 to 85% accuracy with our analysis tools, which is, you think about how much less manual intervention there is if you can at least get to that 80 to 85% marker. And would it be ideal if we could hit 100%? Certainly, but from a practical perspective, that last 5, 10, 15% is a bigger cost. If you can hit 85%, you've hit the bulk of it and are able to get a very good understanding of the costs, the systems that are impacted, and perhaps some of the maintenance actions that are having an impact on your EWIS reliability. So that was kind of talking about the maintenance data itself, but the next step and the next item on the scorecard is about risk assessment and EWIS risk assessment. And there's a lot of elements that have to be captured and knowledge that has to be gathered in order to really do a good EWIS risk assessment. This requires understanding and knowledge of the aircraft's electrical system, a full aircraft environmental evaluation, identify the information zone by zone, identify the types of wires, cables, connectors, splices, how they're used in the aircraft, and really have a good understanding of how those components degrade. I just listed a couple of the EWIS components, but there are a lot more components that make up the EWIS. To get a risk assessment of a existing fleet, it's important to understand the current health of the wiring system components. This must all be combined and be part of the evaluations for the failure modes and effects analysis, FMEA, FHA, failure hazard assessment, system safety assessment, and other failure analysis techniques for understanding the consequences of failure for each system. And this could include bent pin analysis and fault tree developments. Now we go on further, look at the physical impact of failure, proximity of the wire harnesses to critical components like the fuel tank, hydraulic lines. This is a lot of information, and I list this and it can seem like a scary list of information, but as we go through the next couple of steps, and next couple of slides, I hope you see that this is something that is achievable and can be done. The EWIS risk assessments that are described in Mill Handbook 525 are actually in line with industry standards. The FAA put out an advisory circular supporting their EWIS requirements, and advisory circular 25.1701-1 is a great source of information, and I certainly recommend those that are interested in the topic certainly read through that. And if you want a shorter summary of that, go to Lectromec's website and type in that keyword, and you'll be able to find several articles that cover that topic. Now, with regard to the EWIS assessment itself, Lectromec has extensive experience conducting risk assessments for both military and commercial fleets. And we support the commercial fleets a fair bit, and it is a lot of information that must be gathered, certainly to ensure aircraft reliability and meet the requirements of the FAA, and no doubt it's the same thing for the military. So the solution for this is already identified. It's part of the MIL Standard 1798, and it's a 7-step process. As you see here, it starts with system safety analysis and then goes clockwise around that cycle. for maintenance data review, aircraft inspection, component testing, risk assessment, impact analysis, and plan of action, and then the reevaluation, which is obviously something that will come a couple years down the road after some of the actions have been taken. Now, what I want to highlight here, obviously, is Lectromec has a unique set of engineering capabilities, proprietary software tools, and we are an ISO 17025 accredited lab, and this whole system here, we can provide a turnkey solution. For those that are already working through this process, working through the MIL Standard 1798, we're happy to work with your team and identify the best approach to help fill in some of those gaps in terms of your knowledge, experience, or capabilities. As an example, with regard to the component testing and degradation, it is a unique skill set. It is something that Lectromec has been working on for decades. And here's kind of a four-step process that describes a typical review of and try to identify how we approach identifying the current and future health of EWIS components. First, we start with the data review. As you can see, this lines up with part of the tasks that you see as part of that 7-step process. Understand the aircraft condition, group aircraft areas into common environmental zones, because although an aircraft may have 60, 70, 80 different maintenance zones, the uniqueness of the environmental zones is relatively limited, and many of those can actually be grouped together. From our experience, we have been able to find that most aircraft only have about 8 to 12 unique environmental zones, and that helps to reduce the total number of samples that must be taken for evaluation. Also, here we're looking at the aircraft conditions. If there is a fleet of tens of aircraft, the variation is probably very limited. But if it's a fleet of hundreds of aircraft, there is potential for different service histories, different number of flight hours, and what we can support is grouping those together and into logical groups of these aircraft and reduce the total number of aircraft that need to be evaluated through this assessment. Next, we come to the removal of samples. At this point the technology is not there for on-aircraft EWIS health assessment. The components must be removed in order to get a good understanding of the current condition and then be able to predict the remaining future performance. Per zone, we're talking about 8 to 12 samples. What this comes out to be is about 15 to 20 feet of wire. Now, it's not much. This is something that we will often pull from retired vehicles for those that have aircraft that are retired, or we coordinate with the teams as part of the heavy maintenance. From the commercial side, you would call this the D-check or depot level maintenance. And we would do this in order to minimize the overall impact on schedule and aircraft availability. Once the samples are extracted, we bring it back here to Lectromec, and first we identify what testing would be best able to identify the degradation of the EWIS components. We perform it in our ISO accredited lab, and the testing evaluates the wire insulation, the conductors, the cable shields, the connectors, and whatever EWIS component that is gathered as part of the sample removal process. That last figure there is based on degradation data. Lectromec was founded back in 1984, and since that time, we have been gathering data on wire degradation. One of the first projects we worked on was with the Naval Research Lab on the degradation of polyamide or Kapton insulation. That was a multi-year project, and in that project, we gathered thousands of data points, different environmental conditions, different ways of evaluating the insulation. And we use that same technique, that same analysis process for other EWIS components, and we can come up with, we have models that accurately predict how a component will degrade over time, and we can look forward up to 20 years and say, here's where you are now, and here's where you're going to be in terms of your degradation at the 5, 10, 15, 20-year mark. Now, as a kind of a visual behind this, we can break this down to the zone, the wire harness. We can break it down to the system. And this kind of red, yellow, green figure on the right side here, you see that we can isolate it to single zones. This can identify this orange zone near the front of the aircraft where you only have 4 years of remaining reliable service life. For those in the military, we know that trying to align replacement and parts can take some time. So having this much predictive capability can be of help. Certainly, if you're planning to retire the aircraft after 10 years, then the wiring condition in the wings, as are highlighted there, they don't need to be replaced. So with this information, you can actually plan focused replacements without the need for full aircraft wiring system replacement. We can clearly identify the EWIS service life and identify the probability of failure due to material degradation. Now here we're focusing on the probability of failure. But the probability of failure only tells us one part of the story. For a risk assessment, it is the combination of the failure probability and the failure severity. For EWIS, the failure severity is more than just the system criticality. It's also it's a combination of the physical and functional impacts. From a physical impact perspective, we're talking about chafing, arcing damage, and so forth. Functional impact is what happens if there's a loss of that system or control of that system. Once you bring together that failure severity and the failure probability, that's where we can start coming up with a risk. And those familiar with military standard 8A2 should be familiar with this risk matrix. This is a representative of a single, when we do an assessment, we don't come up with one matrix, we're coming up with a matrix for each of the system, zones, whatever. So this is just one simplified representation of that. On the left side, we have probability of failure. On the top, across the horizontal, we have the severity of failure. And if we look at zone 1, in its current condition, taking the combination of the failure severity and the probability of failure, you see it's at a medium risk level. But as that system ages, as that zone ages, the failure severity does not change, but the failure probability does. And over 10 years, you could see that it would go from a medium level severity to serious to high. And in order to be risk averse, you would look to do either some maintenance action, regular inspection, or replacement before that 10-year cycle. You can see the same sort of thing with zone number 2, and just how that probability of failure is dynamic. And this is possible with our degradation models. And to bring this all together, the degradation model by itself tells you, okay, we have some components that are going to degrade. But to get to the risk level requires an integration of all of those elements that we talked about earlier. The failure hazard assessment, the electrical system data, all these have to be brought together in order to generate these single risk assessment points. And so you go from this wide breadth of information down to a very simple and straightforward answer for predicting the development and the changes of the vehicle. So now that I've talked about the risk a fair bit, and like any good Lectromec presentation, we have to actually show at least one video of a wiring system failure. So this is a testing Lectromec did a couple years ago, showing kind of what can happen if you have a connector demate while power is applied. Now, it's it's less likely that a connector will demate during operation, but the same sort of event can occur if there is a bent pin, if there is some sort of contaminant in the wiring or in the connector, or either a metal shaving or some fluid. So I'm going to go and play this video here. And so we have a couple pins populated in the connector, and what you'll see is we'll move the one connector on the left side, we'll demate and pull it apart. It's high-speed video, so it's going to run a little bit slow for the first couple of moments. And once there's a break in the circuit, you see there's a lot of arc energy, there's a lot of damage to the wiring components that are nearby. Certainly the wire on the left side is charred and burned. And if you consider that what other systems might have been in this connector, there is the potential for uncommanded activation of other circuits. Now, what are the consequences? Those are things that will be identified as part of the EWIS risk assessment. So when you put that all together, Lectromec has a clear differentiator here on the physical testing with our ISO accredited lab and our degradation models that really have more than 30 years of research behind it that can identify the current EWIS health and remaining reliable service life. And what helps to bring this all together and reduce the total amount of manual intervention is our software tools. Our software tools reduce that labor need, make it easy to do a risk assessment, increase the accuracy, and can easily identify recommended actions for EWIS sustainment. Over here on the right side, we have a testimonial from a aircraft certification manager we recently worked with, and this is actually still an active project. We sent over a quote and a proposal to them, and they reviewed the quote first, as I think we all would, and internally they kind of said that they thought our quote was exceptionally low and was not we didn't accurately capture what the level of effort necessary for the work. But when they reviewed our proposal, they found that the 1.5 man years of labor were properly identified, but we were able to take care of, reduce a lot of that labor through our software tools. And I can thankfully say we're actively working on this project, and they're very happy thus far with our results. So that's all. I realize that's a lot there. I realize that we've kind of covered a lot of ground with regard to the EWIS risk assessment, and I kind of wanted to give you an idea why we feel we're in a good position to actually talk about this. Lectromec has been around since 1984. I mentioned that earlier, and we're uniquely qualified to certify aircraft wiring systems and components. It's something that has been part of this company since day one, and from three levels of three focus areas we have for our company is component testing, EWIS certification, and remaining life prediction. For that first level component testing, pretty much every major aircraft wire producer in the United States uses our lab for product evaluation and product qualification. We do a lot of work with companies out of both Asia and Europe too. So we see the EWIS components before they even make it onto aircraft. We understand how they change, how they evolve, and how they what's going on to the next generation of vehicles. Just a couple key projects I want to highlight here. We developed special proprietary software tools for the FAA and with the FAA for aircraft wiring system risk assessment, and we still continue to use those tools today. The first of its kind EWIS risk assessment on an aged vehicle we performed it on F-16, and you see we have a link to the paper there. We will be providing this presentation. It's over we'll make it part of the handouts later, and we'll also directly send everyone an email with the presentation. But if you're looking for that paper, you also can go to Lectromec's website and then go to the publications, and you can find that paper. And lastly, And the last key project I want to highlight is we've been actively supporting the U.S. Navy's FA-18 SLEP with EWIS evaluations for quite some time. And we're providing reliable remaining service life predictions. We're not a company that's been just dealing with small projects. We're dealing with a lot of the large projects. If you can see the block in the top left, we worked on F-18s, F-16s, B-1s, P-3s. With the Canadians, we worked on CP-140s, the Tornadoes. We worked on a lot of these aircraft, and we've worked on many more. These are just select EWIS evaluations here. We also work with a lot of the aircraft manufacturers in the industry. Right now, we have 7 active projects with OEMs, and here's a list of 6, but there are actually a couple more that are part of that list. Industry participation, we are always interacting with the industry, because although it may seem that the EWIS components and that the EWIS system is not a rapidly changing field, in some areas it certainly is. And so that's why we participate with the SAE. We were a key contributor to the Mill Handbook 525. And I have to thank the Air Force for certainly including this as part of that effort and trusting us with the development of that document. For those that are not familiar, we publish articles on a regular basis and white papers. And you go to our website and go to the blog tab, and you'll be deluged with so much EWIS information, you'll make your head spin, or hopefully you'll just love it and want to talk with us more. And lastly, we're constantly working with the FAA. We're regularly supporting their research efforts and development efforts, and that's really where a lot of we really have an opportunity to work with some of the best minds over at the FAA. So I've been talking for quite some time, and I'll pass it back over to David here for covering a couple more of these slides here.
Okay, thanks, Mike. Just a couple more slides. These are kind of get off the stage slides. I hope by now it's clear that Lectromec is a serious company focused on EWIS and aircraft wiring. I would hate to say wiring nerds, but they would probably take it, or we would probably take it as a compliment. It's what we live for. And because of that, we've got capability that we can bring to you and add value to your fleets. We've talked about a lot of this before, so this is kind of a couple of wrap-up slides. Understanding the current health of your wiring system, understanding the complicated EWIS requirements that are set forth in the MIL standard. What is it we really should be doing in order to become compliant? And then helping you identify the work to address those deficiencies and focus your sustainment needs. As I said at the beginning, and I'll probably say it 2 more times, this is all about reducing your life cycle cost and improving your aircraft availability. And we do those 2 things by reducing the number of no-fault founds, reducing your time in depot, and reducing the time spent on unscheduled wiring maintenance. And these are just quite simply the outcome of a quality EWIS program. But we don't just work with MECSIP managers. We really work best when we're part of a larger team. We partnered with AFRL. We're working today with Pax River and the folks working similar programs for the Navy. Part of an integrated engineering team. We've been subcontractors to your prime sustainment contractors. We work with whoever we need to in order to bring our capabilities to bear on your problems. And just to the right, one more testimonial. You can see this was from a Canadian fleet manager of 9 CP-140s, and a CP-140 is a P3, is a Canadian P3 variant. And with just 9 aircraft, this fleet manager reported back that through a wiring assessment, he believes he saved $70 million in life cycle sustainment costs by knowing what to replace and what not to replace, and when to replace it and when to keep the wiring that's currently in operation. And there's no reason to think that those results cannot be achieved by the fleets in the Air Force as well. So my last slide is certainly everything we do is focused on getting you EWIS compliant, and that's not to make your report card look good. It's really about the health and availability of your fleets, and by being EWIS compliant, it's just going to lead to a healthier, more available fleet and reduce life cycle costs. Again, by reducing no-fault founds, by reducing time in depot, and by reducing unscheduled maintenance. And one thing we haven't really spent much time about is a good EWIS program and a good EWIS assessment done through that 7-step EWIS process will also help identify design vulnerabilities. Do I have a wire in a high chafing environment next to a fuel line? A good assessment will identify those design vulnerabilities. So I just wanted to say it's been a pleasure talking to you. And just know that Lectromec is dedicated to your mission success. We know we've got the experience, the processes, the historical data, decades deep, a unique ISO certified lab and testing environment, proprietary software capabilities you won't find anywhere else. And we think all of this puts us in a unique place in the aircraft wiring industry. So I thank you for your time, and I'll turn it over to Mike for closing thoughts.
Thank you, David. So the last couple of items I want to bring up here, first we have a case study that's available on our website under the publications tab. And if anything that you heard today is piques your interest, certainly, well, one, contact us. Two, there is this white paper that is available, case study, improving aircraft reliability with focused EWIS sustainment assessments. That's available under publications tab. Just want to also say thank you for taking the time to meet with us today, to join us on the webinar today. Don't hesitate to reach out to us. We will be opening up the mics if anyone has any questions that they'd like to vocally express. We also have the questions tab over here as part of the software tool. That there are some questions on there that we will be answering here in just a couple moments. Thank you for your time, and we'll get started with answering some of these questions. All right, so I thank everybody that put in questions onto the sidebar here. So I'm going to go through a couple of them first, and then if anyone would like to ask a question verbally, please raise your hand with the tool on the sidebar. First one we have, will the charts be made available? Yes, they will be. We will have that email out here a little bit later today. If not today, then maybe tomorrow morning. Certainly by noon tomorrow. Looks like I kind of garbled David. I garbled your name there, David. The general's name is David Urich. All right, Corey, you had a question?
Yeah, can you hear me?
Yes.
So this is Corey Boltz, electronic failure analysis, at AFRL. Just, a quick added plug. Mike and Lectromec have always been willing and able to support us. A lot of times, quick reaction. We don't have either the capability or the manpower at the time to support. So thanks for that. One of the questions I receive a lot from the fleet, I've received it numerous times over the past, I'd say, 12 to 18 months. I get a call. Hey, Corey, we installed these wires X amount of years ago. How long do we have left? I frequently refer to them to the F-18 SLEP. I know how successful that program was for you guys and for F-18. I know I talked to Jeff quite a bit regarding that matter. Whenever I get into the details and explain to them the amount of work that it's going to entail, they're quickly discouraged. Is there any kind of abbreviated method? do you need all that test data to put into your software? Is there a quick and dirty way? You know, obviously I think you're going to lose resolution, but do you have any comments, or can you try to address that issue that, you know, if I keep getting those questions, I can offer maybe a secondary option, or just kind of just send them to you. Any comments on that would be useful.
Sir, thank you for the question, Corey, and thank you for the beautiful words of encouragement. With regard to helping fleets if they are looking for a quick and dirty approach, one of the ways that we've done a lot of, as I mentioned earlier in the presentation, we've done a lot of degradation testing. And so we've built models that if we have a good understanding of the aircraft's service history, then we can start with that as a prediction as to where we would believe the current health of their wiring system is. That would be an easier approach for many fleets, since there's not a need for sampling, and obviously there's a little bit of a loss of actual data there. So ensuring that the model matches what's actually going on in the fleet is not there. When we have done the degradation assessment for some fleets, we will often run degradation models using their data and the fleet data to kind of predict where we think our results should fall. And oftentimes we're pretty close. When we find that the results are vary significantly from the test data to the model, that's when we do certainly more investigation, see where some of the degradation might have come from, if there's additional areas that just either they perform better than we expected or perform worse, and just see where our assumptions varied from actual versus our model. Question? Vitar, bear with me a moment, I'll get you. Okay, Vitar, you're live.
Yeah, hi Mike. Nice, very nice presentation,
Vitar,
really. Yeah.
Hello, Peter.
Yeah. Could you hear me?
Please ask your question. Mike? Yes.
Yeah, okay, my question is, you know, before
yes, we can hear you.
Perfect. My question is, understanding all efforts for the service life after the project is completed. The question is, does this EWIS RAT is also available and applicable for the new designs? For example, I am actually working on Arion Supersonic. It's very new and unique program and project for supersonic flights going back to the skies, and we are really interested, you know, to see how the EWIS RAT could help to predict the service life and the maintenance, or you know, any kind of after program completed and certified to help the service life be extended, and mainly how we could apply and use the EWIS RAT for the new program from scratch.
Vitar, thank you for the question. The EWIS RAT was originally designed for new aircraft, for supporting new aircraft design, new aircraft assessment. That's kind of where it started. When we started the EWIS RAT project, it was back in 2001, and it was part of a project with the FAA. And really the idea there was, can an EWIS risk assessment really be done? And the project proved that we were able to do it. So to the first part, is it applicable to new design? Yes. That it's intended to meet all to generate the reports and analyses necessary for EWIS certification. Now, there's certainly some manual intervention there. There's some on-hand engineer evaluation, but the EWIS RAT does help to bring down that total amount of manual labor. With regard to the supporting sustainment, remaining life, that's kind of where you take the EWIS RAT and take it hand in hand with degradation models. And we can identify, we take the environmental information, we take the probability and we take the severity of the environment. We can then take the probability of degradation, failure. We have those models both for the random failure rates and for when the age-related failure rates start to occur. And those can certainly be used to help support determination as part of your EZAP, your Enhanced Zonal Analysis Procedures, and really identify how frequently the EWIS should be evaluated. So Pitar, thank you for that question. I'm going to go back to a couple more of the written questions that we have here. How long is a service life assessment? It really comes down to the scope of the size of the fleet, how much of the data is already being captured by the fleet, the engineers, part of the data that's been already evaluated. The work that we've been doing with the F-18s, that's been ongoing for several years now. But that should not be, I hope that doesn't scare anyone, primarily because that involved 3 different blocks of aircraft, and they were all unique groups of projects. And so in terms of a single risk assessment, if we were told we needed to evaluate this single fleet, it could certainly be done in maybe as little as 6 months. It can be, and it really comes down to where's the data, how available is it, and if actual samples will be tested as part of the effort. So thank you for that question. Next question, what specific technologies do you recommend for testing and identifying no-fault bounds, intermittents, identifying no-fault bounds and intermittents, and which of them has been successful? That's always a challenge. Certainly parts of identify the no-fault, the intermittent faults is a huge challenge. We always hear the anecdotes of people attaching the wiring system to your harness testers, and then you kind of shake the aircraft as much as you can to try to generate one of those intermittent faults. If the intermittent fault is contained within the wiring harness, it comes down to harness testers and some manual intervention. The difficulty there is trying to recreate some of these stresses that occur in flight on the ground. So some of those harness testers do help to address that, to help kind of be predictive in terms of when you might start to see them in the vehicle. That's where certainly we can come in and help with the predictive analysis, and hopefully help to identify when no-fault bounds and those types of some of those aging-related failures are more likely to appear. Next question: what plans does the Air Force have on resourcing and funding of EWIS Sustainment going forward? That's a very good question. That's a big question. That's something that we're always trying to push on the MECSIP team, the MECSIP leaders, to try to help show how the importance of EWIS and how much it. Obviously, we see these memos come out from high up in the armed services, specifically identifying the cost of the problems. So hopefully that helps to better push the armed services to have a greater focus, greater amount of funding towards these efforts within the individual fleets. The certainly on the Air Force side, this falls under MECSIP. And as part of the MECSIP process, they're as part of evaluating the other subsystems, EWIS is part of that, and the funding that goes to that's designated for the MECSIP efforts, some of that would also be allocated, should be allocated to EWIS evaluation and sustainment. Next question. What form does the maintenance data have to be in for evaluation? This is where we work directly with the fleets. The data is already captured in several databases. It's a matter of gathering the information, bringing some of those maintenance data tables together, and running our analyses through that. So we're not just scientists here. Some of us are also computer scientists. So data formatting and moving that stuff around makes us happy. So hopefully that answers your question there. Someone like us to talk a little bit more about the service life graph on slide 11. So let me go back to that. All right. I'll just give a kind of a high-level discussion about this here. This is part of an example of some of the degradation models that we have for various wire types, connectors, whatever. This one here specifically was for crosslink ETFE, and we did a lot of work of this in-house. We actually did also had some funding efforts from AFRL to continue to develop some of this data. Really, the idea is you take the particular, you evaluate the material itself, and you identify, okay, what are the stressors that degrade that material? Is it heat, humidity, mechanical stress? Is it fluid exposure? If the circuit runs hot, does that have an impact? We look at each of those elements, and we do some preliminary testing and look to really see which ones are the heavily weighted factors on degradation. And we start pursuing that. We start evaluating what's more likely going to degrade the polymer. And this graph here represents, I think this is actually an old graph, and I've been reusing it for the last 7 years. At that time, it represented 700 data points. I think with our latest analyses and data we've gathered from projects, we're probably at around 2,000 data points that support this model and kind of or how it extrapolates into different parameters. So we have this type of model for, you see this for here for ETFE, but also other material types and other many of the components that you can find as part of the EWIS. Thank you for that question. Next question. What sort of deliverables are associated with the EWIS risk assessment? Thank you for that question. I'm sorry, we probably should have had that as part of the presentation. The risk assessment, the overall deliverables, we have deliverables associated with each of the tasks. If I go back to one of the slides here, slide number 10, we see that we have 7 steps. And I'm going to focus on the first 6 because reevaluation is kind of restart the process again. As part of the system safety assessment, that's where we're generating failure hazard assessments, system safety assessments at the EWIS level. So that those are individual reports and overall severity of failure assessments of the EWIS. Maintenance data review, we have, that's kind of where we're starting to quantify the level of maintenance actions and costs, try to come up with costs associated with that. So that's individual report. Aircraft inspection, standard inspection report. What goes with that is recommended areas for sample removal. from the aircraft. Which ones are going to be the easiest to access? Which ones are going to best represent the zone and other parts, other environments within the aircraft that have been combined together? The component testing, the deliverable from that is a predictive or a identification of current health of the wiring system, and then the prediction on how it will age over the next 20 years. And that's usually, we break that into 5-year increments, or depending upon the fleet needs, that's sometimes in flight hours. Depending upon the material type also. Some materials degrade faster in operational environments. Some degrade faster if they're sitting on the ground in a hot, humid environment. Now for this fifth task on the risk assessment, that's where we bring together our system safety assessment and the probability of failure, and we're identifying that risk. That's often where we will, this is a cute little figure, but that's, that'll be probably in your executive summary. At the lower level, we're basically generating this risk matrix for the zones, the systems, and the wire harnesses, and identifying where are really the risks, and can they be isolated to certain parts of the vehicle. I'm not going to jump back and forth through the presentation, but that sixth task for recommendations, or if we identify, for example, this section right here of, okay, zone 1 is it's now in the high risk area, or will become high risk in the next 10 years. We may identify progressive inspection, regular inspection intervals. Where should the wiring or the harnesses in that zone be specifically examined? Is there a way to potentially move this from a catastrophic failure to a critical failure? Perhaps the wiring is routed near the fuel tank, and so the reason it's a catastrophic failure event is that if the wiring harness had a arcing event, it would cause the rupture of the fuel tank and ignition. If that sort of system of that failure criticality has been identified, one of the recommendations could be perhaps rerouting or application of a secondary harness protection, perhaps the use of another circuit protection type. All these would be considered as part of that task 6 deliverable. So there are a lot of tasks. There's those 6 tasks, each have outputs, deliverables, and each one of those deliverables usually is a fairly thorough report that covers what was done and potentially recommendations on what should be done. And when we sit, of course, we're not going to come out and say, oh, we believe everything should be replaced and everything's terrible. That's where we work with the engineering teams that are part of the fleet to really understand what is a practical change, and really help to, this is a collaborative effort. So I hope I answered your question there. And we have actually, I just see one last question here. If anyone else has any questions, please either raise your hand or ask a follow-on question. Question I see here is, what are your thoughts on EWIS work unit codes on reducing the difficulty of getting EWIS data out from maintenance? Well, I certainly hope all the maintainers use all the work unit codes properly. If they do, that's going to make things a lot easier. And I know the work unit code has been added to the work unit code structure by the Air Force, and I believe it's been added to the NAMP that the Navy is using. It's just a matter of getting that into the fleets, getting it down to the maintainers, and hoping that they do obviously there's a training there to properly use the work unit code, so that at the engineering level, we can best support their actions and hopefully reduce the total amount of maintenance they need to do on the vehicle. So again, we have one last question in the chat here. Are EWIS risk assessments performed as a one-time event or more of a continuous process? So if we go back, we'll actually go back to the cycle we have here, the 7-step process. If we have a vehicle, we have a fleet, and a system risk assessment has been performed, unless there have been physical changes on the vehicle, the risk or the severity of failure will remain the same. What will change over time is that probability of failure. So what would happen if you get back to this reevaluation process or reevaluation? You take a look at the aircraft. Has there been any real physical changes? Okay, well then, if there have been, focus on a couple of those harnesses or zones where changes have been made, then update the evaluation. As part of the next couple items, maintenance data, that's going to be a smaller event, aircraft inspection. You have all the documentation from the previous cycle, so that's going to be a much quicker, easier process. The component testing would be likely a smaller effort. In the first one, you'll probably want to test from most of the zones in the aircraft, or most of the those 8 to 10 zones that I mentioned earlier. It might be that only 1 or 2 zones might need to be reevaluated. Those are the ones that are showing the highest probability and the highest risk. So will a risk assessment need to be performed on a continuous basis? Kind of, but each subsequent cycle should be easier and achieved at a much more quickly and cheaper. So I hope I answered your question there. I see that we are actually 15 minutes past our time, and I want to thank everybody for all these questions. If you have any more questions, please call, text, email, carrier pigeon, smoke signals. We're always happy to help. We have my contact information is here. You can go through our website as well, and we'll make sure we get the presentation available to everybody and sent out by, hopefully, like I mentioned, either end of today or no later than noon tomorrow. And this was a recorded event, so we will have this published so people can come back to it and listen to it if you want. And give us about a week for that. Again, it's Michael Traskos and David Urich from Lectromec. We want to, again, thank you for your participation on this webinar. I know it's right in the middle of the day on a Wednesday, and you probably have a lot of things to do, but we really appreciate your time today. Thank you so much, and have a great day.